Alright, going in. Alright, so now we're going to be talking about Chapter 13, Section 5. This one's actually really easy, and it's going to build off of everything that we've learned so far about Calculus 1. So this one's dealing with derivatives of the following certain functions.
We're coming from lunch, but we really have to pee.
Okay, keep going. So sine, cosine, tangent, e to the x, and natural log of x. So basically we're just going to be talking about these. All of these are functions that are, very quick and easy to do. It's not a big deal. Hopefully we all know what derivatives are at this point. So this is a graph of sine of x, for example. And the question is, do we know what the derivative of this one is? What would it look like? Well, we can go into our calculator, which for some reason I've closed, and we could graph what the derivative of the sine of x should look like. So let's go into y equals, we'll have sine of x, right? And we should know how to graph the derivative. We would say alpha f2, we want to do the n derivative with respect to x of variables, y variables, enter. So I'm going to do this of y1 with respect to x. So the derivative will be the red line, and the blue line will be the regular thing. Now let's hit zoom 6. Whoa. Do I have a stat plot on? I do. Okay. Got to turn that one off. All right, let's just change the window so we make this look a little nice. Let's go -5 to 5. We'll make this one -1 to 1. And let's hit graph. Okay, so the blue line is sine, and the red line is our derivative. And what you might notice right away is that this red line looks very familiar. In fact, this looks exactly like the cosine wave, because it starts at 1. Let's double check ourselves. So if I just go over here and I say, okay, let the black line here be cosine of x. Let's see what we do. 1 second. Oh, wait, no. Yeah, you can go in now. Yeah, you can go in. Let's see what that looks like. Hey. All right. So the derivative of sine seems to be cosine of x. And in fact, that is true. All right. So the derivative of sine is cosine. Okay, in fact, this is actually all of the tables we need for trig functions. The derivative of sine is cosine. The derivative of cosine is negative sine. And then there's one for tangent. The derivative of tangent is 1 over cosine squared. The way that I remember it is secant squared. Wait 1 second. Okay, go on in. Because 2 ladies walked in from the cafeteria without the notes. I'm just hang on 2 seconds. As soon as they come out, you can go in. So with it, I remember the derivative of tangent is secant squared. So that's it. So we're going to apply these 3 rules to a couple of examples and then move on to the next part of this section, which is pretty easy. So how about this one? Obviously, at this point, you can use the chain rule.
Thank you.
No problem.
Yeah.
No problem. We can use the chain rule. So the derivative of this, well, the chain rule says we got to take the derivative of the outside times the derivative of the inside. Well, the derivative of cosine is negative sine. So I need to do negative sine of the square root of x times the derivative of the square root of x. Well, the square root of x is just x to the 1/2 power. And that means that we would apply the power rule to it. The power rule basically says I got to bring down the 1/2 and this would be x to the negative 1/2 power. To the 1/2 power meaning square root. So I'm just doing this brute force style. So the derivative of the outside is negative sine, and you just copy down the inside. Then you do the derivative of the inside. Obviously that looks ugly. Let's clean that up a bit, and we will get y prime is equal to negative 1/2. There you go, buddy. To the negative. Go on in. That was yours, I think. Okay. Cool. X to the negative 1/2 power times the sine of square root of x. Sorry, I'm in the hall right now doing some bathroom duty. Yeah, so you clean it up. You generally want to put all your numbers out front and put your x values out front, and the sine is on at the end. We can clean that up a little bit more actually, because if we were in college, this would not be very, very acceptable. We'd want to clean this up even more, so we would have a fraction like this. Negative sine of the square root of x on top, and then 2 times the square root of x on the bottom. So if we really wanted to clean it up, this would be fine for me, honestly. But if we really want to clean it up and make it look super nice, it would actually look like that. So we would actually pass this back down to the other side. Square roots are kind of nice to look at, so we let them have it. And that would be that. What's the next one? Go on in. Next one says x cubed over sine of x. All right. First of all, we always want to copy that down, so we'll have this. All right. We can do the power rule in conjunction with the product rule or in conjunction with the quotient rule. In this case, I feel like the quotient rule today. All right, go on in. I feel like the quotient rule today. So, it's pretty simple. It's going to be the derivative of the top times the bottom, so 3x squared times sine of x. Then you say minus the derivative of the bottom times the top. Well, the derivative of sine is cosine of x, and we have to multiply this by the top, which is x cubed. I'm going to actually put that out front just to make it look nice and neat. This is all over the bottom squared, and we represent the square of sine by saying sine squared of x. But it's the same thing as saying sine of x times sine of x, so really not a big deal. Honestly, this is enough for me, but in the college level, this would not be enough. We would want to actually simplify this a little bit more, So we probably want to factor out an x squared from this term and an x squared from this term. So we'll have x squared times 3 sine of x minus x cosine of x, all over sine squared of x. And that's pretty much as far as you need to go for like a college level thing. All right, that's the second one. Last one, we got this one, x squared tangent of 3x. All right, x squared tangent of 3x. Again, this is all stuff that we should be pretty familiar with. We're just introducing new functions into our toolkit. This one, we should apply the product rule. So the derivative of the first thing times the second thing, that's 2x times the tangent of 3x. Then we would add the derivative of the second thing times the first thing. Well, here we got to be a little bit careful, okay? First of all, we would just copy down x squared, because that's the thing on the left. Then we're going to do the derivative of tangent of 3x, but here we have to do the chain rule. So now we'll say the derivative of the outside, which is just going to be secant squared of 3x, but then we have to multiply it by the derivative of the inside, which is 3. So as you can see, things start getting a little hairy when you start adding more and more rules. We have to use the chain rule, the product rule. We got to remember certain things about derivatives of trig functions, blah, 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 blah. See? Starts getting a little weird. Now, with problems like this, we would want to clean that up a little bit. The 3 can come out front here, so we can make that look a little nicer. Now, this is enough for me, but if we were in college, this would be unacceptable. All right, first of all, we need to have this memorized, that tangent is just sine over cosine. All right, and secant is just 1 over cosine. So tangent is just sine over cosine, and secant is, 1 over cosine. we would want to combine these a little bit, so we'll need a common denominator. I think this 2x should be in the numerator, so let's go ahead and do that. And this 3x squared should probably also be in the numerator, so let's do that. Just going to rewrite this so it looks a little neater. Let's put these up here. Okay, so in order to get a common denominator, we'll have to multiply the top by cosine. And what are we going to get? And then we could add it. So now y prime is going to equal what? 2x sine of 3x cosine of 3x on top plus 3x squared all over cosine squared of 3x. So in the college scene, we probably want to clean that up and make it look a little bit like that. Maybe we could factor out an x too. Come to think of it, there's an x there. Is that yours?
Yeah.
Okay, cool. All right, go on in. See, there's an x there and an x there. We could probably factor out an x to clean that up a little bit. So if you were taking a calculus course, your professor would probably want something that looks a little bit like this. It doesn't simplify much more than that, but honestly, this is acceptable. Just show me that you know how to do the product rule and we can walk away happy, okay? Okay, and that's just the basic example of using your trig derivatives here. These are going to be in your formula packet. The derivative of sine is cosine, the derivative of cosine is negative sine, and the derivative of tangent is secant squared, or just 1 over cosine squared. Okie dokie, and that's that. Now, let's move on to the next part, the derivative of e to the x. Okay. So this is a special function, which has some pretty interesting properties. So let's go back over to here, clear that out, and we'll say, okay, second e to the x power. Okay. Now, the blue line is going to be my function, and the red line is going to be the derivative of the blue line. Let's see what we see. Hey, that's interesting. The blue line came first, but then the red line goes directly over it. In fact, they are exactly the same. And that's actually a way to define e. It is the derivative of e to the x is actually e to the x. And that's something to point out. Okay? So, looking at this thing, let's do some of these. Now again, you see these look a little complicated. It's really not that bad. That's it. Okay. I think that guy's gone. I think there's one more that I'm missing here, right? Yeah. So now we need one more thing, and that's the derivative of the natural log. Where did we go over that yet here? Oh, that's the next section. Interesting. Cool. Go on in. Well, anyway, let me just go ahead and wrap it up for you right now. So what about the natural log of x? Okay. All right. So if I clear this out and I say, okay, well, what's the derivative of the natural log of x? I would actually use this button for the natural log of x. We hit enter, and let's see what the graph is and what the derivative of this one is. Remember, the natural log is the opposite of e to the x. Okay, so if I do that, the blue line does this and the red line does that. That's interesting. Why does it do that? What is this graph? Well, it's actually a pretty commonly looked graph. It's actually 1 over x. So if I hit 1 divided by x, I hit graph, and it's exactly the same thing. The only difference is we have to do the absolute value of 1 over x. Okay? So notice that if I clear this out, we don't actually have the red line as a negative. And it makes sense if you think about what the natural log means. All of these x values are positive. All right? Which means all of the y values here should also be positive. Cool sauce. So the inverse should also have positive y values, and this one should have positive x values. So that's why we don't actually get the function 1 over x. It should be 1 over the absolute value of x. That's the literal definition of the derivative of natural log of x. Okay? And that should be in here, I think, but whatever. Let's actually do a couple of these right here. That'll show up in here, I think. Oh, shame. That should be 1 over the absolute value of x. I think high school is actually giving you a good break there, but it should be 1 over the absolute value of x, meaning x should always be positive. If it's negative, make it positive. Anyway, let's do this first one as a cool example. All right. So y is equal to 2x plus the natural log of x. Okay, so here we need to find out what y prime is. We're going to do the chain rule. The derivative of the outside times the derivative of the inside. Well, remember, the derivative of e to the x is just e to the x. So the first thing I have to write is just copy it down. 2x plus the natural log of x. But then I have to multiply it by the derivative of the inside. Well, the derivative of the inside is pretty easy. 2x turns into 2, and then the derivative of the natural log of x should be 1 over x. Okay? Actually 1 over the absolute value of x, if I'm being very, very, very strict. There we go. 1 over the absolute value of x. And honestly, you can leave it pretty much like that. Oh, wait. You know what? I know what they're doing. I know what they're doing. I'm so silly. No. I'm so silly. Now, this is actually super easy. Back up. I don't need to do that. So let's use laws of exponents here. Okay? Before we take the derivative, let's see if we can't make this a little bit more digestible. So using laws of exponents, this is just going to be this. All right? Whenever you're adding exponents, it's the same thing as multiplying the bases. I'm recording. It's the same thing as doing that. Okay? And oh, look, e to the natural log of x, these actually cancel out. And you'll be left with y is equal to e to the 2x times x. There we go. And traditionally, we like to put the x in front of the e. Looks a little bit better that way. But yeah, now this is a lot more digestible. I mean, don't need the natural log for that. So y prime is going to equal what? Well, it's going to be the product rule. I need to take the derivative of the first thing times the second thing, so I'll just have e to the 2x. And then plus the derivative of the second thing times the first thing. Well, the derivative of the second thing, I have to use the chain rule again. So it's going to be the derivative of e to the 2x. Well, the derivative of e is just e to the x. So first things I need to do is say e to the 2x. And then times the derivative of the inside, which would be the derivative of 2x, which is just 2. I imagine that people watching this video are going to say, huh? Because they have no idea what just happened. But reminder, the product rule is just going to be u prime v plus uv prime. Okay? It's the derivative of the first thing times the second thing plus the derivative of the second thing times the first thing. So the derivative of x is just 1. So that's why we get this part. This part's the same as this part. And then we want to take the derivative of the second thing. Okay? So this is the same as this. Well, here we just copy down the first thing and we get an x. And the derivative of e to the 2x, we'll use the chain rule. And we say the derivative of the outside, that's what this is, times the derivative of the inside. Now this is almost fine for me. You definitely want to put the 2 out front. This is honestly fine for me, but if we were in college, this would not be fine. We would want to have, factor this out a little bit. So we'll have e to the 2x plus, like times 1 plus 2x. This is the fully simplified version, and this would be what would be acceptable at a college level. All right, I just factored out an e to the 2x. Easy peasy. One more. How about this one? Okay, this is y is equal to the square root of x squared plus e to the 4x power. Very cool. Now this is not in a calculus-friendly format yet, so what we're going to do is change it up. by saying, all right, this is x squared plus e to the 4x raised to the 1/2 power. Go on in. And now we can do stuff. So how about we say, okay, power rule. Derivative of the outside times the derivative of the inside. That's the chain rule, but I'm going to use the power rule for that. So this is going to be what? 1/2, and copy this bad boy down. All right, and 1/2 minus 1 is negative 1/2. So if I'm showing my work as I go, this would be the derivative of the outside. The 1/2 comes down out front, then you subtract 1 from the exponent and you get this. Now you have to multiply by the derivative of the inside. Well, the derivative of the inside is pretty easy. This is going to be 2x, because that's going to be the derivative of x squared, plus the derivative of e to the 4x. Well, again, you have to apply the chain rule here, and you're going to say the derivative of the outside times the derivative of the inside. Well, the derivative of e to the x is just e to the x. Then you multiply that by the derivative of the inside, which is 4. So 4 e to the 4x. So once again, this is the derivative of the outside, and this is the derivative of the inside, x squared plus e to the 4x. Now, this is honestly fine for me, but again, this is not fine at the college level. So we want to clean that up, make it look nice and neat. What would this look like in the college level? It would look like this. 2x plus 4 e to the 4x all over 2 times the square root of x squared plus e to the 4x. Yeah, there we go. That's fine. Now we want to cancel stuff out, so the 2, we can factor a 2 out of both of these and cancel it out with that 2 on the bottom.
Who are you talking to?
I'm recording. I'm making a video for my class.
Bathroom, it's so late that she let me take my stuff, or else I'm gonna be late.
It's okay. Don't worry about it. So we factor out a 2 out of both of these, and what are we going to get? So we cancel stuff out. That 2 goes away, and that goes away. Cool. This would be fine for a college level class, right there. Okay? Okay. Last one, we got this one right here. Boy, that looks really random. Not a problem at all, though. There we go. That's pretty nice. Thinking. I'm trying to think of a good trick for this one. I want to try and simplify that a little bit. There is a way to simplify this a little bit. So let's rewrite this a bit. You're hearing a lot of noise because I'm in the hallway. So that negative exponent is the same thing as like writing it as a fraction. So we'll have 1 over e to the x power. Okay? And 1 over e to the x power here. So it would look like this. We can make common denominators. What's up? Go on in. Can I help you? I think it's you. All right. And over here, we're going to have e to the 2x over here over e to the x. Have a good day. You're cool.
I was helping Josias the other day.
Hold on a second. Sorry about that. Well, I tried to cut out some of the sound there. Anyway, here we are. Obviously, you don't have to do all of this stuff, but I think it's a little easier to do it this way. So I get a common denominator on the top and a common denominator on the bottom. I can add, and then I'll get this over e to the x all over this divided by e to the x. And I can cancel this 1 over e to the x, 1 over e to the x on the top and the bottom, and I end up with this. This is all before taking the derivative. But because I simplified it, it makes my job a lot easier to do. So now I can apply the quotient rule. All right, the derivative of the top minus the times the bottom. So the derivative of the top is 2 e to the 2x, and then the derivative of negative 1 is 0. So whatever. And I have to multiply that by the bottom. Then I have to subtract the derivative of the bottom times the top. So I'll have e to the 2x, e to the 2x minus 1 on top. All over the bottom squared, so I'll have e to the 2x plus 1 squared. This is just me using the quotient rule just to make my life a little easier. Okay, this looks scary, but it's actually a lot easier than you think. Notice that on the top I have e to the 2x and e to the 2x, so I can factor that out. And what do I get? Cool. Alright, so when I factor it out, this is what I get. Inside here, this 2 can distribute to that one and that one. Let's go ahead and do that. Yeah.
Wait, oh, I can't go or I can?
You can, I think. Okay. So let's distribute this 2 to both of these to see what we can see. Cool. Go on YouTube. And let's... Alright. This negative can distribute to each one of these, and we'll get what? So that negative goes there. And that goes there. So both of that happens. Okay, now 2 e to the 2x minus e to the 2x. What do we get? We're just going to get positive e to the 2x on top. Notice what I'm doing. I'm just simplifying as I go, seeing what we see. 2 plus 1 is 3. Right. And, yeah, I think that's about as simplified as we're really going to make that, you know? Okay. Have a good day. I don't really see how we're going to simplify this anymore, so that would be an answer for the college people. Honestly, for me, you know what, as ugly as it looks, if you left it like that, I'll be cool, but it would be a lot better if it looked like that. It looks a lot simpler and cleaner, you know what I'm saying? And that's the deal with e to the x power. It's pretty easy stuff. And apparently they simplify this even more, which is fine. Doesn't matter to me. As long as you get the right answer, it's totally okay. So their form is a little bit different than my form, apparently. That's not what I meant to do. Huh. Okay. I think it's because I did that first trick a little differently, where I just set it up like this instead. That's why my answer looks differently, but if I were to graph this and graph that, it would probably look the same. But somehow theirs looks a lot nicer than mine, which is too bad. Anyway, here we go. Derivative of the natural log of x. So this is the one where it's 1 over the absolute value of x. Okay. Now, I don't know why they have in the definition that it's 1 over x. That's not true. The derivative of x is going to equal... Okay. The derivative of x is always going to equal 1 over the absolute value of x. You do not let x equal 0 or less. In fact, here we go. This agrees with the fact that for x is greater than 0, the slope of the graph is always positive. So it should be the absolute value of x. They're just not putting it in there. They're saying x is greater than 0 just to make our lives more difficult. Okay, whatever you want to do. So yeah, let's try it. The derivative of this. Okay, let's give it a shot. Again, we're applying the chain rule. Yeah, going in. So what do we got? Natural log of 1 minus x squared. Got to find the derivative. All right, well, again, we got to use the chain rule. So this is going to be, all right, well, the derivative of the natural log is 1 over x. In this case, it looks like, you know, this is always going to be, I guess if we have to confine x to a certain value in order for this to be totally true, it has to be the case that everything inside this natural log must be greater than 0. Otherwise, this is not going to work. So we have to restrain our x value a little bit. But let's ignore that and suppose that they've already done that for us, please. And we'll have 1 over x squared here. And the derivative of the inside, well, that'll be times minus 2x. All right, so this is the derivative of the outside times the derivative of the inside. That looks awful. We can change that to make it look a little bit nicer. Minus 2x on the top. This would be an answer that I would accept. Okay? Easy peasy. Let's try this one over here. F of x is going to equal what? All right, the natural log of 1 plus x over 1 minus x. Here's, okay. Cool. Cool. Now I look at this thing and I'm like, well, I could make this a lot easier by using laws of logarithms here. Okay? All right, going in. Is that yours? No, that's not yours.
Yeah.
What happened? Are any of these yours? Did you have a pass?
Yeah. Somebody must have taken it.
Well, have a good day. I don't know what happened. What's up? How's it going? So let's use laws of logarithms to make this work. Before we start anywhere, we're going to have, all right, natural log of 1 plus x minus the natural log of 1 minus x. For those of you who don't remember laws of logarithms, anytime that anything inside the log is divided, you can subtract them. Anytime that you're multiplying anything together, you can add them and turn it into this. It's a law of logarithm. It's understood. It's pretty basic stuff. Okay? Now, my life is a lot easier. The derivative of the first thing is super easy. F prime of x. So the derivative of the outside is just going to be 1 over 1 plus x. And the derivative of the inside is just 1. Nice. Now what about the second one? Well, all right, minus the derivative of the outside is 1 over 1 minus x. But the derivative of the inside is now negative 1. Which one's you? Okay. So if the derivative of the inside is negative 1, I can change this minus sign to a plus, and then I'll have this. This is enough for me, honestly. But if we wanted to be really, 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 really cool, we would want to do something where we combine them. So we'll do a common denominator, and in the top we're going to have, you know, this should be pretty easy stuff. Common denominator stuff, 1 plus x times 1 minus x. This is an algebraic rule, but this should be 1 squared minus x squared. So a plus b times a minus b is always a squared minus b squared. That is an algebraic rule. You should have that memorized, but if you don't, I understand. And then, right. Let's see. Minus x plus x is 0, and 1 plus 1 is 2. So if we wanted to be very, very, very strict, I would want you to fully simplify it to this. 2 over 1 minus x squared. But in my class, for now anyway, you can leave it like this. But I want you to practice your algebra skills and see how far you can simplify it. That would be the best, if you don't mind. So if we're fully preparing for college, I'd want you to get a common denominator and simplify it down. this would be acceptable for a Calc 1 class in college. Cool. Cool. All right, that's natural log, and that's it. If you guys have any questions, let me know. Take care. Bye-bye.